Today we're talking about inequalities in one triangle. You talked about inequalities in algebra, and when you talked about them, you said, okay, you can have one number is greater than or less than or equal to another number. And so just as a reminder, those are the symbols that we have: greater than, less than, and then we can also add a line underneath each of those, and that gives us the equal to portion, right? So greater than or equal to, or less than or equal to. And so that's going to be really important as we go through this. Then, sorry, got rid of our picture for a second. Then the second thing that you need to know is that you can only have an inequality like A is greater than B, okay, where A and B are both numbers, if you could add a number to B so that it would actually be equal to A. So for example, you could have 5 is greater than 2, or you could have 5 is greater than 3, because you could say, okay, 5 is equal to 2 plus 3. They could have chosen any numbers that add up to 5 there, so you could also have gotten something like 5 is equal to 1 plus 4, which means that 5 is greater than 1 and 5 is greater than 4. Okay, but if you weren't able to plug those numbers in and create an actual equation with an equal sign, right? Equation means equal sign, then you would not be able to write an inequality. Okay, so just kind of keep that in mind. It's an important property as we go through that. Next, we're going to look at some properties of inequalities. Okay. And these properties are found on page 344 in your book, if it's easier for you to copy them from there. So again, that's page 344. All right. So the first property, the comparison property, just says that you have to be able to compare any two numbers using either a less than, an equal to, or a greater than symbol. Okay, so that just says we can compare any two numbers. They either have to, like, one has to be less than the other, has to be equal to the other one, or it has to be greater than the other one. Okay, the other properties you're going to notice here, the last three properties, these are all properties we dealt with equations, right? When we talked about properties of real numbers, you should have a table that has all of these properties for equations listed out on a blue sheet in your notes. If you don't, then you want to go back and add those. And it's going to be really helpful if you just copy these down. We'll use them a little bit more in class, and we'll talk about them there. So it's important that you know that they exist at this point, and it's important that you know where to find them. Okay, so I would put them in your notes, just copy them down, and when we get around to using them a little bit more, then we'll have those to refer back to, and we'll add some little notes on the side of those. Okay, so we're going to skip over them for now, but I want you to know that they're there, and they do need to be copied into your notes. Okay, so moving on, we've been talking a lot about triangles, and so we want to know how can I use inequalities to talk about the parts of a triangle. So remember that on triangles, we have sides, we have angles or vertices, and then we also, remember that for angles, they can be divided into two parts. You have interior angles on the triangle, like angles 2 and 3 in this picture, and we have exterior angles of a triangle, like angle 1. Okay, and hopefully you remember that we could write an equation that says this angle 1 would be equal to angle 2 plus angle 3, right? We said that was one of the rules we learned when we talked about triangles before the Christmas break, okay? Now, you're going to notice that based on what we just talked about what it takes to make an inequality, that means that we can say this angle 1 is greater than angle 2, and we can say that angle 1 is greater than angle 3, okay? And I know that all these little symbols start to look a lot alike, so it may be helpful for you, instead of writing everything in the same color, to go ahead and do like your greater than, less than kinds of symbols in a separate color or highlight them or something like that. So this is one place where color can be really helpful. Okay? And so from this, we actually get the exterior angle inequality. And this inequality, this property, is listed on page 345 in your book. And so from this, they said, okay, you can always take the one exterior angle, and it will always be bigger than the two remote interior angles. Okay, so the one exterior angle is always bigger than either of the two remote interior angles by themselves. Okay, so that's going to be one property, and it's going to be really helpful. So let's see if we can write an inequality here. Okay, so we're looking for our one exterior angle, that's angle 4. Okay, and we're actually going to be able to write two inequalities. So angle 4 is going to be greater than the two remote interior angles. So remember, the remote interior angles are the two angles that are farthest away from that exterior angle and are on the inside of the triangle. So that would be angle 1, okay, and angle 2. Okay. You can't write an inequality about angles 3 and 4 unless you actually know the measurements of those two angles. Okay, so right now the only thing we can say is angle 4 is bigger or greater than angle 1, and angle 4 is greater than angle 2. The next piece of information that we're going to talk about is how can I tell about angles and sides and which ones are bigger and which ones are smaller. So sometimes we don't actually need to know all the measurements. We just need to know which one is the biggest or which one is the smallest. Something like that. We want to be able to put them in order. So what you're going to notice here is that whenever we can identify the largest angle, for example, in an obtuse triangle, the obtuse angle is always the largest angle. The side that is across from it will always be the longest side of the triangle. Okay? Same kind of thing happens when we look at the smallest angle. If we know that one of the angles is the smallest angle, then the shortest side of the triangle is across from the smallest angle. Now, that only helps us find the largest side and the largest angle, and the smallest side and the smallest angle. But if you can get those, then the two like the angle and the side that are left over, those go in the middle. So if we were trying to say list the angles in order largest to smallest, or sides in order largest to smallest, we could still do that because the angle that's left over, in this case angle C, that would be the medium angle, and the side across from it would be the medium side. Okay, so let's try an example. So on this triangle, they've given us the sides, and they would like for us to list the angles in order from smallest to largest. Okay, and that order is going to be really important. You have to be sure you read the directions. So we're looking for smallest first. Okay, so we want the smallest side. So we look at these and we see, okay, 11 is our smallest side. That means that the angle across from it, angle B, okay, is our smallest angle. So angle B would be listed first. Okay, so this is our smallest. Now, next we're going to jump to the largest. So our largest side is this side AB. It's 15 units long, and the angle across from that side is angle C. So angle C is our largest angle. And then the side that's left over is this 14 unit side, and the angle that's left over is angle A. And so it goes in the middle. So you're always going to find the largest and the smallest first and put them where they need to go. And then whichever angle or whichever side, if it asks the other way, is left over, that one is the one that goes in the middle. So here we were just asked to list them out, smallest to largest. And so a lot of times they'll ask you to do that. They could also give you the angle measurements and ask you to list out the sides, smallest to largest or largest to smallest. That's also a possibility, so be on the lookout for that. And then finally, we have two relationships that come from this. And the first one says that if you have one side of a triangle is longer than another side, okay, then the angles opposite the longer side has a greater measure than the angle opposite the shorter side. So all we're doing is we're taking the information we just learned before, and instead of putting these in order, we're just writing an inequality. So for their example here, this side is 9 units long, and this angle Z is across from that 9 unit long side. And so 9 is larger than 7. So we know that angle Z then on that triangle has to be greater than angle X, because you'll see here this side is 7 units long, the angle across from it is angle X. And so angle X has to be smaller than angle Z. So you could actually write this inequality this way, where you could say angle Z is greater than angle X. They might have asked you, like if they left you a fill in the blank, they could also put it as angle X is less than what angle, and they could leave a blank here, and you'd have to say it's less than angle Z. Okay, so just be prepared. It could be written either way, depending on the directionality of that greater than, less than sign. Okay. The second theorem that's on here is one that says if you have one angle of a triangle, okay, so this time we're starting with angles, has a greater measure than another angle, then the side opposite that angle is longer. So this time we're starting with the angle. So this time we have angle J is across from side KL. So we know that side KL is bigger than side JL because it's across from the smaller of the two angles. And so we could write our inequality that way. Notice that for all of these we're dealing with measurements, so when you're writing these you don't actually need the lines over the top of the KL and the JL. I look forward to seeing you tomorrow in class, and thank you for listening. Have a great afternoon. Goodbye.